and then click on Start Graphing, okay? So this section is on what's called parametric functions. Parametric functions are a different way of representing graphs and things like that. And the cool thing about parametric functions, as we will see in just a minute, is since you're introducing a third variable, t, you can graph things using parametric functions that are not actually functions in terms of x and y, things that fail the vertical line test, okay? And so you can do some more fun things with them than you could do with other stuff, all right? So the first thing we're going to look at, it says plot the graph of this parametric function in degree mode. So when you guys are on Desmos, to get into degree mode, the default is radians, so you will have to change this. To get into degree mode, you hit the tool button, and then this menu pops up. Do you have your phone, Danica? Okay, go ahead and get on desmos.com or open the app if you have it. And then change this into degrees, okay? So anytime you start Desmos, it's always by default in radians. So we need to change this into degree mode. Then the first thing we're going to do, okay, so we're graphing this in parametric mode. So what that means is, what you can see here is instead of y equals something x, I have x equals something t, and I have y equals something t. So the way that you graph this on Desmos is you go parentheses, and then our first equation is 5 cosine t, so I'm going to type that to start with. 5, and then the cosine is in the function menu, so I'm going to go 5, whoops, I don't know why that went on the outside of those parentheses. I don't know, I just do it out of habit now. So I'm going to go 5 cosine, and then I find t in the regular keyboard menu. Okay. Then I'm going to go back to the other menu, close that parentheses, and put a comma. And then what was the other one? 7 sine t? Anybody remember? Yeah. Okay, thank you. So then I'm going to hit 7, and I'm going to go sine, and then back to the keyboard menu of t. Okay? And then I get to decide what I want my t values to be in between. You can see that the 0 and the 1 are kind of ghost highlighted there. I want to do better than that. I want to do bigger numbers than that. What do you guys want me to do? 0 to 50. Okay, so let's do 0 to 50. All right. Yeah. That is awesome. Is not enough because we are in degrees. So if we want to go all the way around, right, I'm going to go 400 first just because I heard Mylena say that first. Yeah, sorry about that. I erased your stuff. 400 actually will complete the cycle for us. What do you think the smallest number we'd have to put in to, right? Because we're trying to go all the way around once, I'm guessing, not 100% sure, but guessing, yeah, if we go, okay, yeah, 360 gets us all the way around also. Kai wants to check and see if 350 makes it. It does not quite. Yeah, right. So, yes, so what we came up with here is an oval. The math word for that is an ellipse. Yeah, 360. I'm going to, being a being a math teacher, I'm going to go with the correct term, which is an ellipse. You guys can refer to it however you want. How do the equations that we graphed relate to the ellipse? Yeah. Awesome. Okay, so the equation says 5 cosine, and this distance is 5. And then it says 7 sine, and this distance is sine. And if you look up here, you'll notice that sine goes with the y, and cosine goes with the x. So that's why those come out to be like that, okay? So this is a parametric equation because you have an x and a y both in terms of a third variable t. So like I said, we are now able to make a graph of something that is not a function. This fails the vertical line test. Yeah. X, y. What's that? Yeah. Yeah. Okay. So Kai wants to get a little bit crazy with the cheese whiz here and change this into tangent to see what happens. And if you do that, what the heck? Then you get, yeah, that's tangent. Okay. So I don't know. Okay. I think it's flat. Yeah, I think it's to 50. Oh, with this graph? Okay. So let's change this to 50. And so you just don't see as much of the thing. Now, tangent has a period of 180, so it's possible with this one if we plug in, so if you plug in 180, you only get the top half. And then if we plug in 360, okay, 270, then we get 1.5 of it. Yeah, that is pretty weird. All right, so at least for the sine and the cosine, we can use our trig relations thingy to figure out why this comes out to be the way it is. So if I want to take x equals 5 cosine t and y equals, 7 sine t, and change that into something that only has x's and y's, which is this fancy phrase right here. That's a Cartesian equation relating x and y. Here's how I do it. Are you ready? Okay. I'm going to take this and I'm going to divide both sides by 5. Okay? When I do that, the 5's here cancel, and I get cosine of t equals x over 5. Okay? I'll show you in a second. This one right here, I'm going to do the same thing, but I'm going to divide both sides by 7. Okay? So then that tells me that sine of t equals y divided by 7. Okay? Are you ready? Okay. So in other words, I took each one of those equations and solved it for sine and cosine. Okay? All right, then I'm going to square them both. Okay? Janessa and Danica, I know that we're using our phones today for the graphing, but please don't let them distract you from the learning at hand. Okay? I'm going to square them both. So cosine squared equals x squared over 25. Okay? And then sine squared equals y squared over 49. Okay? Okay, Mylena's freaking out because I haven't really explained like why I'm doing this. Here is the big reveal. What I'm going to do now is I'm going to add those two equations together. Because if I add cosine squared plus sine squared, what do I get? 1. So now the cosine and the sine are gone. And then if I add x squared over 25 plus y squared over 49, I just get x squared over 25 plus y squared over 49. And so what I have done right there is called, I have eliminated the parameter. I got rid of the t. Okay? Does that make sense? So now I have this in terms of x and y because I use the fact that sine squared plus cosine squared equals 1. Yeah, right. So now that I've done that, if I wanted to, I could come back here and I could graph that instead of doing the parametric thing. X squared over 25 plus y squared over 49, thank y'all, equals 1. And then you would see that we would get the same thing, yeah, with just an x and a y. Okay? Yep, it's going to be, your assignment is going to be asking you to make some graphs that look in a particular way, but then also to change the, yep. No, you'll be fine. I'm sorry, what? I did. I saw that there was an egg on Instagram that got the most views or likes or whatever of. To me, that represents everything that's wrong with this generation. That's such an. I don't have an Instagram account. Okay. Okay, let's do the next one. It says, plot the parametric equations. This time we're going to go x equals 6 plus 5 cosine t and y equals negative 3 plus 7 sine t. Any guesses, any thoughts before we do this on what that's going to do to the graph? How far? Okay, Danica says she thinks it's going to go down 3. Negative 3. What's the 6 going to do? A stretch of 6. Okay. So maybe a stretch of 6, maybe a down of 3. Let's let's take a look. There's no pressure. It's not a big deal. So I'm going to go 6 plus 5 cosine of t this time. What? Right, but for us to enter parametric equations into this program, we need to put them in parentheses, x as the first one, y as the second one. So 6 plus 5 cosine t, and then negative 3 plus 7 sine t. Danica, you shouldn't have bailed out. Oh, are you kidding me? Good thing I'm smart. He thought I screwed up. Yeah, you were right. So what that does is it takes the same ellipse and it moves it 6 to the right and down 3. Okay, the 6 to the right because this is the x, and then the down 3 because that's the y. Mylena said a stretch of 6. How do we get stretches? Right, you multiply by 6. So if I change this into 6 times 5 cosine t, then you could, well, I can't see it because it got stretched out so much, then it would be a stretch of 6. Okay? Yeah, that's absolutely right. Yep, you got it. I don't know if you should or you shouldn't, but I can sure give it to you. The general equation for ellipses is x squared over a squared plus y squared over b squared equals 1. Okay? And this will be an ellipse that goes a units left and right, and it will go b units up and down. Okay? So yeah, great question. And I don't know if we're ever going to mess around with the Cartesian formula of having would have a center of 0, 0. You can change that. I'm not sure if we're going to get into that or not. I know we did with this right here, but I guess we'll find out in a minute. Okay, so when it says describe the effect of the constant 6 and negative 3, what would you say? Over 6. To the right 6 and down 3. Okay, good, because we're adding or subtracting. Okay, and you should notice in this case, unlike the ones that we've done before where moving to the left or to the right is the opposite, this time a plus 6 did move it the way that you would expect. So parametric equations are a little different in that regard. Okay, Danica? Cody asked if there was a general equation for ellipses, and I said there is, and so I just, nope. I don't think that we've done that. I think it's a later chapter in the book. He asked, so I showed it to him. Okay. Then you need to step out in the, okay. I'm sure they'll leave a message if it's important. Yeah. Not necessarily. I think it's more, you know how your attention is, Gus, what are you doing? Gus? Okay, okay, please stop. The way your attention, somebody said, was like the sine wave. The difficulty of the class is a little bit like that too. This is easy because, so that makes it boring. Things you don't understand. What don't you understand about this? Well, I mean, we just did stuff on the graphs. It's not hard to. Yeah. Okay. Right. Right. Yeah. Mylena? Uh-huh. Because it told us. It said x equals 6 plus 5 cosine t, y equals negative 3 plus 7 sine t. So, hang on. So, anytime it says parametric equations, you go x, comma, y, what they tell you. Okay? Yeah, and it'll always be with t. Danica? They're the same. Oh, you mean this one here? Oh, don't stress about that. That was just Cody and I having a... So this one? Okay, sure. So in this form, it would be, let's try that, see if that helps. X minus 6 squared over 25 plus y plus 3 squared over 49 equals 1. That's those two equations in regular XY form. Yeah. Yeah. Does that help you, Cody? Okay. You got it? Okay. So it would be, I mean, yeah, if we went through the steps to solve it, it'd be the same thing as what we did with the other one. I would have to take that and solve it for cosine. So I'd subtract 6, divide by 5, right? And then I would square that. So that's where this comes from. Same thing here. I would add 3 and then divide by 7, and then I would square it. And then sine squared plus cosine squared equals 1. So those two things added together would equal 1. Okay? Okay. I'm a little disappointed, Olivia, to hear that you're bored or whatever, or you don't like this, or I don't know what. Because, no, it's not my favorite, but what we're going to do next, I think of as being something fun that you can do with this. But before we get there, maybe this would help also. This is the general parametric equations for an ellipse. H and K tell you the x and y coordinate of the center, and A and B tell you how far to go in the x direction and how far to go in the y direction. And of course, what would happen if A and B were equal? Then it would be a circle, yeah, because it would stretch the same amount in both directions. It would not make an A. What's that? Yeah. Radii is just plural of radius. I got it. I got it. All right, ready? Okay, so what we're going to do with these is we're going to make some pictures. Okay? No, you're not. Yeah. All right, so here's what we're going to do. We're going to make this picture, okay? Um, so this is just an ellipse, right? Okay, so we can come up with the equations for those. X equals, how far has it been moved in the x direction? 11. And then what's the so-called radius of that circle? How far? Yeah, because we want the middle. So that is 11. No, the middle. Oh, you're doing this one? Okay, you want to do that one first? We're going to end up doing both of them and the line. That one is at 2. Okay. How wide are those from the center? From the middle. What's like the radius? It's a little bit more than 1. Yeah, so maybe 1.2. And then that's cosine of t because the x is always the cosine. If I go from here to here, that's a little bit more than 1. Okay. All right. Then for the y, what is the y coordinate of both of those? Yeah, we're making a 3D image on, doesn't it? No, the y coordinate of the. Oh, sorry, you're right. 5. Okay. I thought that was the. I thought that line was the. Because you're up 5. Okay. And then yes, the radius in the y direction is 1, 2, 3, 4. So that's plus 4 sine of t. Uh-huh. Well, they just did. Well, let's see. I mean, do you think that's a 3D image? Yeah, so we can replicate. Right, so yeah, so you just answered your own question. We're just going to, I'll show you. Okay. Okay, so then we have to graph the top line and the bottom line. Okay. This line right here is y equals what? The one on top. Y equals 9. Okay. But that line only goes from here to here. Okay. What are those x values? Gus, pay attention. 2 and what? Okay, so that goes from 2 to 11. Okay? Because this is not parametric equation, this is like restricting it. And then this is y equals what? 1. And that also goes from 2 to 11. All right, so let's put that together. Let's graph that on the calculator screen and see what we have won. Okay? So the first thing, so the first thing that I'm going to do is I'm going to put in the, you guys want to do the close by circle first because you kind of freaked out when I went over here. All right, so that one was, the x was 2 plus 1.2 cosine t. So 2 plus 1.2 cosine t, yeah, cos. Then, comma, where's the comma? Okay. 5 plus, what? 4 sin. Okay, and then we need this to make a complete circle. We need to go from 0 to 360, right? Okay, so there is the left end of our cylinder. Okay? All right, now let's make the right side of the cylinder. Okay, so that's the same thing except for the x coordinate got moved over a little bit. So you just have to change that to be 11. Okay. Yep. Synth. Forcing. Don't quit forcing it. Okay, so there's the right-hand side. Okay, And then to restrict the top, I did y equals 9. And you were correct. Oh, it gives me a thing right here. So I want that to go from what to what? 2 to 11. Okay, that's not what I wanted. Maybe the step has to go by ones. No. Oh, sorry. Okay, that's not what I want. Let me see if I just go 9 and then do the fancy brackets. Hold on just a second. Give me a second. What did I say? 2 to 11. So 2 is less than or equal to x, which is less than or equal to 11. There we go. Okay. All right. And then the other one was 1, same thing. So I guess I just didn't need the y equals. And then I have to do fancy brackets and then go from 2 less than or equal to x, kind of, yeah, less than or equal to 11. Okay? So there's the cylinder. Cynicism is so draining. If we wanted to, we can change it all to the same color. So I just make this all red. Okay, we're good. Why is it thicker? Did I click on something wrong? I don't think I can change the thickness. I can change it to, oh, there we go. Okay. All right. Okay, now you guys are, I mean, I don't know what you're really saying. Can you, let's see, never mind, I got this. You can do, people do crazy illustrations with these things, which I'm not sure. Well, let's go, no, will you type in Desmos drawings? Okay, so people have done all kinds of crazy things using this kind of, yeah, you want to just take us for a ride through there? Just taking this idea of parametric equations and being able to make different stuff. Okay?
Wait, no, Danny DeVito is Danny DeVito. Wait, no. Mylena, go up and show the Danny DeVito.
Okay? Will you click on this one for me, the Batman one? Go up. Click on that one. Okay, stop right there. So you can see that people are getting pretty serious with it. Okay? This one has some square root stuff in there, some absolute value stuff, because from an absolute value you get a V shape and stuff like that. But there's really no end to the amount of creativity that you can show. That is very cool.
I just couldn't see it. I was looking at the formula.
Yeah, the formulas that they're putting in are pretty intense, okay? I am not going to ask you guys to do anything that complex, okay? If you want to make Danny DeVito or any other thing like that, you're certainly welcome to. I would love to award lots of extra credit to you if you do something creative like that, if that's what it takes to encourage you. Well, you would now, since you ruined it and said that you're just going to cheat. I'm sure that you guys